Sharding and replication are almost always done together. So whenever you've got a sharded environment, and here I'm showing three shards, S0, S1, and S2, and a MongoS routing them. The shards themselves are replica sets, and they're replica sets because otherwise they wouldn't be reliable. So you just have to sort of expect that when you're dealing with a sharded environment, and best practices dictate that that's the way you would set it up. Next thing I wanted to point out is that the MongoS is sort of doing what the driver was doing before, in the sense that the MongoS is reconnecting to members of the replica set, because the MongoS probably has a connection all the way through to the primary node of the replica set in each of these shards, and possibly connections to the secondaries if it's allowing secondary reads. So when there's failover within a shard, it's the MongoS that's going to reconnect. And so the MongoS has some concept now of this seed list and knows which of these nodes are part of it. The next thing that you should realize is that there's still this concept of write concern, and there's still the J value and the W value and the W timeout. And those are going to be passed right through. So if your application specifies that it requires journaling to be true, let's say, or W majority, a majority of nodes need to see the write before it's completed, then your application is going to specify that, and the drivers are inside your application or next to your application, your drivers, and that's going to go to the MongoS. The MongoS is going to route the query to the appropriate shard, the replica set, and then that J and that write concern are going to get reflected in that final write. So you should continue to think about having to specify those in the sense that there's a replicated environment here, and that those are still meaningful. And they're going to apply to each of the nodes. Now, so if you did a multi-update that hit multiple nodes, then in each node, if you said I wanted the W value to be, let's say, 2 and J to be 1, then this MongoS wouldn't get an acknowledgement for that write. It wouldn't complete it until all the different nodes completed the write to a majority of them, and that it was committed to the journal on the primary of each of these replica sets. Those are some things to keep in mind as you're working in this environment. And the final point I'll make is that usually MongoS is replicated itself. So there's probably a few of these hanging out here. Typically, you run them on the same box as the application server itself because they're pretty lightweight. And the driver is just the way they can take multiple names of hosts for a replica set. They can take multiple MongoS's, and if it can't for some reason attach to a MongoS or connect to a MongoS, then it will connect to another MongoS. And the Python drivers itself have classes just for dealing with shard environments, and you can see them inside the driver docs. So anyway, that's what I want to kind of point out to you about sharding plus replication together, that you've got these replica sets here, and you have these MongoS's in front, and everything you learned before about availability and replication still applies. It's just that it's passed through to the various shards. All right, let's do a quiz. So suppose you want to run multiple MongoS routers for redundancy. What level of the stack will assure that you can fail over to a different MongoS from within your application? Is it the MongoD, MongoS, the drivers, or the sharding config servers?